What we're going to focus on is on the evolution of the enterprise search. And the evolution of enterprise search really started out with content, document stores, and generation one search engines like Alta Vista. Does anybody remember Alta Vista out there? If you do, thank you for being closer to my age. If not, well, that's fine. You're probably not born when Alta Vista was around, but that's okay. In those days, it was pre-Google, and there was a large group of them that thought they would never find one common search across the entire world. And Google said, I disagree. And of course, Google happened, and that was sort of the event horizon. And then after that, the industry split into web search, Google as we know today, Bing as we know today, and enterprise search, which really focused on the enterprise world. So let's talk about the evolution of enterprise search. So the first rendition of enterprise search was essentially what we call keyword search. And that was where everybody manually tagged their documents, primarily to put them into categories, very much like the old card catalogs in libraries. But you would hire interns. They would go through the documents and tag them with all the important terms. And then those tags became keywords, and that's what you searched on. It worked, required a lot of manual tagging, and of course it had human error. At some point, there was the invention of what they call the inverted index, which was, let's get away from a relational database model and completely invert that concept into a new thing called an index. I mean, Google obviously popularized that. And it's interesting to say, people wonder, how is it possible that Google can search just about everything on the planet? And I'd say, well, it doesn't have to have that large a number of records in its database, because it probably, and I'm way oversimplifying this, but a Google search index for the English language, or for the English search, is probably about 150 to 200,000 records. And the reason for that is because that's about how many words are in the English language. So what they're doing is they're actually storing records by word, and they're doing name value pairs. Now, attached to that word is an immense table of every place that word is found. And it much more complex than that, but that's basically the concept of what an inverted index does. So for you folks who are relational database familiar, and my background way back when was one of the chief architects over at Sybase, and I'd be amazed if anybody can still remember that company, Sybase. But in any event, the way to look at it is that it's a self-referencing, totally denormalized double table schema. But in any event, that's what an inverted index does. But it allows you to provide real, true text search. You don't need keywords anymore. You don't need tagging, because it actually searches through the text. Now, at the time, and it's still true today, the primary items that you search are nouns and noun phrases. Because when you think about it, the nouns in a stream of text are probably the most important identifiers of what is actually being said. Then we graduated text search into what we would call semantic search, and semantic is really trying to find the meaning in the text. Remember, this is more about the data than the query. And so natural language processing was born, and again, I'm sort of playing fuzzy with some of the terms here to simplify things, but it realized that, there was more than just nouns and noun phrases. There's full part of speech annotation or parsing, where verbs are important because they are the foundation of relationships between the nouns. And then adjectives and adverbs are important because they can lay open the idea of sentiment and in general context. And so sentiment analysis became a very popular outcropping from search. Then let's fast forward all the way to what everybody has been calling AI search. I mean, we've been saying AI search, and this enterprise search industry has been saying it for 15 years now. And AI has meant an awful lot of things over the last 15 years, but I think chat has managed to take it into a context that becomes real. It's a very, very clever and brilliant introduction because, of course, it's wonderful creator of clickbait. So, 2025, 95% of all reporting, news reporting will be generated by AI. so I have to read that, of course. And that's, if I don't know how many of you've played with ChatGPT, but it's pretty awesome at what it does. The underlying technology, though, isn't as new as as most people think. And AI search really started to bring in the idea that now that we have access to so much data out there and great computing power, we can train on that data, find patterns in it that are used to automate, or at least to improve or integrate or iterate the quality of what we're using it for, which in this case is to improve search queries. And we can get into more detail about what supervised and unsupervised training is, but and machine learning and deep learning, but we'll hold that off for another discussion because that can go on forever. But it introduced the idea also of graph queries and vector queries. And the vector query technology is the underlying search capabilities behind ChatGPT, for example. We would propose that if you had to continue this evolution, that a deep search model is really embracing everything that you see in the past here, but understanding how to semantically relate content across structured and unstructured data stores, to be able to appreciate and take advantage of the cardinality and the relationships on the relational side, as well as all the metadata that's declared within the table infrastructure. And then to take search to a level where it's no longer what you purchase as much as what enables what you purchase. And that introduces the notion of matching engines and automation. Because there's one thing that search really did not pay much attention to until very lately, and that is the third dimension, which is time. Fourth dimension, which is time. And it's understanding the change in data over a period of time. That change in data is very important in very specific markets, so we're going to talk about a few of those.